Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Currently we are in the third module of this course where we are studying different types of engineering materials. In this lecture, we are going to see what are the non-metals like conductors, semiconductors and insulators, their classification and applications. So, what is a conductor? First thing, conductor, semiconductors and insulators are directly related to the concept of electricity. So, when we are dealing with electricity, we have to know what is a conductor, what is a conducting material, what is a semiconductor and semiconducting materials, what is a insulator and insulating materials. So, we should have the knowledge of these materials so that we can work with them easily. So let us see what is a semiconductor. First one is conductor. So what is a conductor? A conductor is a device a conductor is a material which will allow the flow of electricity through its body. Simple. So the examples of conductors are silver, copper, aluminum. Even gold can also act as a very good conductor because it is very costly because of its property called malleability. Okay, gold is not so used in, it has many very less applications. Even though it is used in some computer body chips and etc. We have some amount of gold present in them. So, the first thing is silver, copper, aluminum. So, among these three things, copper is widely used in the electric industry where it can be used to prepare wires, switches, etc. Okay, and then resistance. We should know what is resistance. The property of a substance which opposes the flow of electricity is called resistance. Okay, after conductor, we should know some definitions in order to study or understand the coming topics. So, resistance is the property that will not allow the flow of electricity. And specific resistance. Specific resistance is the resistance between two opposite faces of a cube of that material. Suppose if I have a cube, this cube will have faces. Suppose this face is X and this face is Y. So it has two faces. All these two faces will act differently. Like the X face will have a different resistance compared to Y. Why is that? Because depending on different factors, these two faces will have different resistance. So when we compare the resistance of X with Y or Y with X, we have a new resistance called specific resistance. And then superconductivity. At very low temperatures, some metals acquire zero electrical resistance and zero magnetic induction. So at very low temperatures, some materials will behave like complete insulators. There is no magnetic induction also. So the property is known as superconductivity. Some of the important superconducting elements are aluminum, zinc, cadmium, lead. So these are some of the examples of superconducting materials where their resistance will be zero, absolutely zero, that they will completely make the flow of electricity through them. Okay, so this is examples of superconductive elements. And then we have applications of superconductors like the cryotron. Cryotron is a superconducting material where these are used to prepare flip-flops. We know in electronic devices we have flip-flops which are made up of this cryotron. Analog to digital converters are also made up of this cryotron. And counters, line drives. So all the semiconducting devices or electronic devices, circuit boards are made up of this cryotron. And then we have electrical machines. It is possible to manufacture electrical generators and transformers in exceptionally small size having an efficiency of 99.99%. So the superconductors are the materials which will have absolutely zero resistance. They are superconductors. They can easily conduct any amount of electricity through them. Even a very small amount of electricity can be easily flown. Now, this transforms exceptionally small size very small sized objects can be prepared with this type of superconducting materials, which has very high efficiency of about 99.99%. And then we can prepare electromagnets. It is possible to produce superconducting solenoids which do not produce heat during operation. By the use of superconductivity, it is possible to design electromagnets for the use in laboratories for low temperature devices like maser. Okay, so what is an electromagnet? We know electromagnet is a device which will be magnetized when electricity is passed through it. So solenoid is an example of electromagnetic object, where the only problem with the solenoid is when electricity is made to flow through it, it will induce magnetism. At the same time, it will be heated due to the flow of current and magnetic induction. The solenoid will be heated. Why? Why it is heated? Because of the resistance of the material. The material itself will have some level of resistance to the flow of electricity. Even though resistance is very small, it will make the solenoid very hot. So in order to avoid this, we can use superconducting materials like cryotron for the preparation of solenoid, so that we can make more effective magnetism. And then we can simply prepare or manufacture power cables with superconductors. Now, let us see the classification of electrical conductors. So there are many types of conductors are there. So as of now, we are seeing this materials of low resistivity. So materials of high resistivity. There are two types of conductors here, materials of low and high resistivities. So we will compare these two, why they are materials of low resistivity and where they are used, similarly high resistivity and where they are used. So materials of low resistivity used for making conductors of all kinds of windings needed in electrical machines. So if we have a electrical machine, we will use some kind of copper windings in them. So this is a low resistive element. Because of its low resistivity only, copper is widely used, and also it is very cheaper when compared to some other materials like gold. Gold has very low resistivity when compared to copper, but it is very costly. So in electrical machines or apparatus or devices, transmission and distribution of electrical energy, we can use these materials of low resistivity. Some examples of this low resistivity are copper, aluminum and steel. So these materials have very high conducting capacity. That means they have low resistivity, obviously. And then we have second type of materials, that are materials of high resistivity used in making thermocouples. Okay, the thermocouples, resistance heating devices, etc. So these are all used for like they are high resistive elements. They can be used in different applications based on the type of application where high resistance is required. Like I take the example of a stove, electric induction stove. Here what happens, when electricity is made to flow through the stove, it will get heated. Now what is the use of heating? Because this heat can be used to cook food. Now how can I use a superconducting or a normal low resistive element for this? This low resistive element does not have any resistance and it will not heat. It will simply make the electricity to flow through it. Now what I need is, I need a material of high resistivity, like I need hot water or I need to cook some food. For that I need heat. So whenever I take the high resistive element, I will make the electricity to flow through these wires. These wires, when electricity is flowing through them, they will heat up. While because of the resistivity, they will heat up. This heat can be used for particular application. So some materials of high resistivity are manganese. So it is a combination of copper, manganese and nickel. And then we have constantan, which is a combination of copper, nickel, chromium. And then we have nichrome, which is a combination of nickel and chromium. And then we have carbon. So carbon is also a high resistive element. So these are some of the classifications of conductors. Then We'll see what is a semiconductor. Semiconductors are solid metals. These are solid materials. These are non-metallic elements or compounds which allow electrons to pass through them so that they conduct electricity in the same way as metal. So semiconductors are the materials which will behave like conductor as well as an insulator depending on the particular situation. So the main characteristics of this semiconductor are their resistivity is usually high. Their resistivity will be very high, but at a particular time they will act like a conductor so that they will allow electricity to flow through them. Okay, so this property makes the use of semiconducting devices very rapid in the field of electronics and computers. So the temperature coefficient of resistance is always negative. So whenever there is a temperature and electricity related thing, this will always be negative. That is why it is used as a semiconducting device. The contact between semiconductor and a metal forms a layer which has a higher resistance in one direction than the other. So in this we have in previous pre-UG like pre-undergraduate course we have studied this semiconductors where we will have different layers. When the layer is excited from one layer to another, the electrons will be excited. The flow of electrons will be seen. That means the conduction of electricity will be seen only after a certain temperature or a certain time. So depending on the temperature or depending on the amount of electricity passing through this body, it will make the electricity flow or it will stop. Okay, it will act as an insulator. See, the contact between semiconductor and a metal forms a layer which has higher resistance in one direction than the other. In one direction, it will have higher resistance. In other direction, it will have low resistance. So it depends on the type of semiconductor we have designed. Okay, when in some suitable metallic impurity, arsenic, gallium, etc., is added to a semiconductor, its conducting properties changes appreciably. Okay, so metallic impurities are added so that the properties will be improved. Semiconducting properties will be improved. So they exhibit a rise in conductivity in increasing temperature. With the decreasing temperature, their conductivity falls off. Simple. When the temperature increases, the conductivity will also increases. Okay. So this is another property of a semiconducting device. Okay. Whenever there is a falls in the temperature, the conductivity will decrease. Okay. At low temperature, semiconductors become dielectric. This is also very important. So when the temperature is high, conductivity is also high. When the temperature drops, conductivity drops for a semiconducting material. If the temperature is below the absolute or it is near the absolute zero value, what happens? The semiconductor device will act as a dielectric material. So what is dielectric and how dielectric nature will work, we'll know in the coming slides. And then we have some semiconducting elements. These are boron, carbon, silicon, germanium, phosphorus, arsenic, antimony, sulfur, selenium, tellurium, iodine. So these are the symbols and a group in the periodic table and their atomic numbers are there. So these are some of the examples of semiconducting elements. So these semiconducting elements has this unique property that they will act as insulators at their regular temperature, right? At room temperature, they are insulators. When they are excited or heated, they will act as a conductor. Okay, they will allow the flow of electricity to flow. Okay, now let us see what is the classification of semiconductors. As we know from our previous courses, from pre-university courses, we know that there are two types of semiconductors. We have studied this very well in physics. Intrinsic semiconductors and extrinsic semiconductors. Now let us see what is an intrinsic semiconductor. So it is a pure form of a semiconductor. Hence no free electrons are available since all the covalent bonds are complete. So in intrinsic semiconductors, there are no free electrons. They are completely covalent bonds are formed. There are no free electrons so that they will not convert into a conductor easily. They will take more time. A pure semiconductor therefore behaves as an insulator. So this is an insulator almost, but when the temperature or some conditions are changed, this may act as a semiconductor. It exhibits a peculiar behavior even at room temperatures or with rise in temperature. So whenever there is a rise in the temperature, what happens? It exhibits some peculiar properties like it will act as a semiconductor or it will act as a conductor with the rise in temperature. Okay, the resistance of a semiconductor device decreases with increase in temperature. Okay, the resistance will always decreases when it is heated. So that when the semiconductor is heated, it will make the electricity to flow. When an electric field is applied to the intrinsic semiconductor at a temperature greater than 0 degree Kelvin, conduction electrons move to the anode and the holes move to the cathode. Hence, semiconductor current consists of movement of electrons in opposite direction. This is very important when we study the working of a conductor. The flow of electrons will be different. They will be moving from, see here, electrons move to the anode. In this semiconductor, electrons will move to the anode. Generally, they will move to the cathode. Okay. So, in this semiconductor, the flow of electrons will be opposite to a conductor. So, because of this, this semiconductor is called as intrinsic semiconductor. And then we have extrinsic semiconductors also. In a pure semiconductor, which behaves like an insulator under ordinary conditions, a small amount of certain metallic impurity is added. It attains current conducting properties. See here, previously intrinsic semiconductor is a pure form of a semiconductor, but not this one. This is an impure form, like a small impurity is added in order to improve the semiconducting properties. The semiconducting properties are developed by the addition of this impurity. So impurity is not a foreign object that is added by without no use. It is added on purpose to improve the properties. So the process of adding impurities is extremely in small amount, like about 1 part in 108 parts, like about 1% of impurity is added to a semiconductor to make it extrinsic, to improve the properties. So this process is called doping. So the process of doping is nothing but to improve the properties of a semiconducting material. We are going to add some kind of impurity or other material, that is this process is called doping. So we have doping agents. What is a doping agent? Pentavalent atom having 5 valence electrons called donor atoms. Trivalent atoms having 3 valence electrons, these are called acceptor atoms. Depending on the type of semiconducting material we have, we will add either donor atom or acceptor atom. Suppose if I have free electrons, I will add acceptor atoms like gallium, aluminum, boron. So this metal will accept the covalent electrons, free electrons. If pentavalent atoms are added, like if there are requirement of electrons into the metal, semiconducting metal, so this donor atom will donate electrons to this metal. Okay. So this is all about extrinsic semiconductors, doping, and then we have doping agents. We have 2 types of doping agents, donor and acceptor atoms. And then let us see what are the applications of semiconductors. So copper oxide and selenium were the first materials to be used as rectifiers. Literally, these are the first level of semiconductors. Copper oxide and selenium. And then we have germanium and silicon. Semiconductors find wide use in both high frequency and commercial frequency circuits, particularly as non-controlled rectifiers. Now see, germanium and silicon has many applications in the semiconducting industry where they can be used to in both the fields like high frequency applications and consumer frequency applications. They can be used in both applications. And then we have non-linear resistors, also varistors. These are semiconductors which are resistance is made by dependence on the applied voltage. Okay, so varistors are nothing but depending on the voltage, the resistance will change. Resistance, the semiconductors whose resistance is marked by the dependence on the applied voltage. If the voltage is changed, the resistance will change. So this is the application of non-linear resistor where semiconductor materials are used. And then we have temperature sensitive resistors. These are also called as thermistors. Now these thermistors are very important. apart from varistors, thermistors are also important. What is the use of this thermistor? Depending on the temperature, thermistor will make the uh, flow of electricity, or it will cut the flow of electricity. Suppose if we take the example of an air conditioner, I have set the air conditioning temperature to 24 degrees centigrade. What happens if the room is cooled up to 24 degrees centigrade? This thermistor will measure the temperature and it will send a signal. That means it will cut off the power supply by simply inducing resistance. Okay, by simply inducing resistance to itself, it will cut off the power supply. What happens? Because of this, there is no extra usage of electricity. Okay, so that is why thermistors are very useful in the case of air conditioning systems and refrigeration systems. Okay, so thermistors, they possess a negative temperature resistivity of high absolute value. So this temperature sensitive resistors, which are shortly called as thermistors, these are used in temperature control machines like air conditioning and refrigeration systems. And then we have insulators. So what is an insulator? Insulator is simply an object which will not allow electricity to flow through it. So far we have seen conductors which will make the electricity to flow through them even at any condition. They are called as conductors. And then we have semiconductors which will not allow electricity until they are excited or the temperature of it is increased. Okay, after the temperature has risen, they will allow electricity to flow through them. But whereas insulators, these are completely insulated materials that they will not allow any amount of electricity to flow through them. So these are insulators. So these are defined as materials which offer very large resistance to the flow of electricity. And for that reason, they are used to keep the current in proper path along the conductor. So the best example for this insulator is plastic. So all the plastic wires which are insulating the copper wire on which we will make the electricity to flow. So these are protecting the copper wire. When we touch the copper wire directly, when it is electrified, we will get electrolytic. That means we will get a shock. So we are protecting the copper wires with plastic. So this plastic is a very good insulator. Because of that, it is not allowing electricity to come out. Even though we touch a live electric wire, we will not be experiencing any shock. So let us see the characteristics of an electrical insulator. It should be large insulation resistance, high dielectric strength. It should be having high dielectric strength. It should not be depending on the temperature, its insulation should not change. And it also should have uniform viscosity so that it will give a uniform properties. Okay, when we see the electric wire is uniform throughout the length. Okay, it is not different shape or size. Okay, why? Because the electrical wire which is a resistor, which is an insulator, this insulator is having a uniform viscosity, that it will have uniform properties throughout its length. And then it should be uniform throughout. It keeps the electrical losses as low as possible and least thermal expansion. Depending on the temperature, this insulator should not expand or contract. This may cause damage to the body. When exposed to arcing, should be non-ignitable. When there are any sparks or when there is a short circuit happening, then the risk of sparks will be more. So this insulator material should be very resistant to ignition. It should not be burned easily. Okay. So this is the characteristics of insulator. And then we have classification of electrical insulating material. So classification according to the substance and materials. So depending on the type of materials used, we have three types: solids, liquids, and gases. In solids, we have mica, wood, slate, glass, porcelain, rubber, cotton, silk. So these are all the examples of solid insulators. So we can touch them. We can actually feel them. They are solid in structure and they can be used to insulate electricity. Solid mica, wood, slate, glass, porcelain, rubber, cotton, etc. So all these things are, even plastic is also used as a insulator for electricity. Yeah, here we have rayon, terline, paper, cellulose material. So these are all the insulators, solid insulators. And then we have liquid insulators like linseed oil, refined hydrocarbon, mineral oil, spirits, synthetic varnishes. Uh, these are also called as liquid insulators. And then for gases, we have dry air, carbon dioxide, argon, nitrogen. So this is why argon lights are used. So what is an argon gas? Argon gas is a inert gas which does not allow electricity to flow through itself. So that is why olden days we have incandescent bulbs. In these incandescent bulbs we have argon gas filled inside, so that the filament which is burning of the electricity will not make the electricity to flow through the argon. And also argon itself acts as a non-burning agent, so it will not make the filament to blow off. Okay, so after some time on the long usage these bulbs will blow off because of the filament is blown, but not the argon gas. Okay, even the tube lights in olden days also have this kind of inert gas filled in them. Now let us see the classification according to the temperature. So there are different classifications based on the temperature at where the bodies will act as insulators. So Y, class Y, this is the class by which we are defining all the insulators. So this is class Y, where assigned limiting insulating temperature is 90 degrees centigrade. And then we have A, materials of class Y impregnated with natural resins to improve the property, so that the temperature at 105 degrees centigrade also, this will act as insulators. Above 105 degrees centigrade, it is no longer an insulator. It will be conductor. And then we have E class, synthetic resins, enamels, cotton, paper, laminates with formaldehyde bonding. So these are all comes under this thing, where the temperature resistance is good up to 120 degrees centigrade. And then we have B class. So this is mica, glass fiber, asbestos with suitable bonding substances, build up mica, glass fibers and asbestos lining. So these all these materials will have a temperature resisting of 130 degrees centigrade. So below 130 they are good insulators. And we have F class, materials of class B with bonding materials of higher thermal stability. So these materials will have a insulating property of up to 155 degrees centigrade. And above that, they are no longer insulators. And then we have H class. And then glass fibers and asbestos materials and built up mica with silicon resins. So here we have a good insulating property up to 180 degrees centigrade. So, and we have C class also. So these are mica, ceramics, glass, quartz, etc. These are all good insulators even above 180 degrees centigrade. So when we are designing for higher temperature environments, we should always go for C class, depending on the temperature conditions. If there is no temperature condition, we should go for Y. Okay, Y class is better. Cotton, silk, paper, cellulose, wood. So these are all normal materials which can be used for insulating electricity. And then when the temperature is above 90 degrees or above 180 degrees, we should go for different materials. So depending on the materials and their temperature conditions, the electrical resistance will change. So we as an engineers, we have to choose a material which is correctly matches the application. And also we should keep in mind the factor of safety. We should never use a 90 degree centigrade temperature resistance material where the surrounding temperatures are around 80. Because we can simply say the temperature is near 80 degrees centigrade, we can select 90 degrees centigrade temperature object. But it is not true, because we have to take into consideration the factor of safety. Sometimes the temperature which is designated about 80 degrees centigrade may increase about 100. So that is when these materials will fail. So the same thing is happening with the electric bikes. Nowadays electric bikes are being used rapidly. Those batteries are being charged overnight and they are being used rapidly during the daytime in hot sun, where these batteries does not follow standards. So the battery makers does not follow these standards, and they are creating fires. The batteries are blown up, and they are causing big damages to the bikes and as well as the persons. Okay. So that is all for this lecture. So far we have seen what are the different types of conductors and their applications. What are the different types of semiconductors, their classification, applications. And then we have seen what is an insulator and its applications and types. Okay, depending on the type of application, we have to select a particular object. We want to completely insulate, we have to take an insulator. If we want to use a semiconductor, we should keep in mind that at a certain temperature, it will act as an insulator. And after that, it will act as a conductor. So depending on the temperature. So the semiconductor is a very crucial device which is used in all electronic devices. So that is all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.